Hello everyone, welcome to my class. This is lecture 170. We'll be discussing the portal frame with different conditions. So let us take a problem in which the portal frame is intermediately hinged. If this problem comes, how we'll tackle this problem? We'll go step by step. Let us see, this is a portal frame having point joints A, B, C and D and carrying 16 kilonewton point load 8 mid. The dimensions are 1.5, 1.9. So in this first step, we'll go for distribution factor. What is distribution factor? We go for joint member K, sigma K and K divided by sigma K will give you distribution factor. This is what we keep on doing. So let us see what is the value of this way. Let us try to understand this thing. We'll hope we'll succeed in resolving this problem. If this problem comes, so joint, let us take the joint B. The member are BA and BC. We are not taking this member C because this all moments are 0 at this point. This K is I by 4 and this is BC. BC is 3 by 4, I by 3. So this is also I by 4. So your K is equal to 2I by 4 and this half and half. You try to understand because this in this hinge. So BC will give you 3 by 4 and this is fixed. So this is giving I by 4. That is the values of moment distribution factor. Next step, let us go for what you call non-sway moment. We can have the idea from this portal frame, the support conditions are not uniform, although the loading is symmetrical. So there will be sway in this portal frame. So let us go for non-sway analysis. We will find MAB, MBC, MCD, MDC 0 because there is no loading. What about this thing? MBC you will give. Let us draw the configuration A, this is a B, this is C and this is your D. A, B, C and D. How is the sign of this moment? So this is like this is in this way, this is in this way, this is in this way, this is like this and this is like this. So this is anti-clockwise negative, so this is clockwise positive, so this is negative, this is positive, this is negative and this is positive. This is the moment sign we have assumed in this way. So your BC will be negative and BC is negative, that is minus WL by 8 because this is in the center. So this is 16 into 3 divided by 8. This you will be minus 6 kilonewton meter. Now you can find out MCB also. This will be WL by 8. This will be positive. So this will be 16 into 3 divided by 8. This is 6 kilonewton meter. So these are the final moment which we are getting. We can distribute this moment in like this, in this way. Let us see how this will be done. This is your B point. This is one half, and this is your C point, because this is 0, so we are not considering this thing. So what about this? This is 0, this is 0, this is 0, and this is 0, and this how much? This is minus 6.0, this is plus 6.0. Let us observe the point C, which is hinge, so there will be no moment, so you put here minus 60, so this will be minus 30. Will go. So let us finally draw the moment. This will be your 6. This is your 6. So this is minus 9.0. This is 0. This is 0. This is 0. And this is 0. So this is your moment. So let's distribute it. Plus 4.5. Plus 4.5. This is 0, 0, 0. Let us try this thing. So this will transfer because fixed 2.25. This will be your 4.5. This will be your minus 4.5. This is 0, 0, 0. This is your final moment. So very easy. It's not very difficult to understand. So these are the final moment which is of non-sway. Non-sway के जो moment है, we are getting like this. So we can finally write over here the non-sway moment 8 A, B, C and D. 8 A, this is like this, this is like this, this is like this. 8 A, how much? Plus 2.25. 8 B plus 4.5. 8 C minus 4.8 B minus, and rest 0, 0. Okay, there is no problem. We are getting the moment D in this way. What will you do? You try to find out the sway force which is exerted because of this moment. Let us see how it will solve. So let us take the AB. This is your A and this is your B. This is a fix. So moment is 2.25 plus clockwise. This is 2.25 clockwise. And this is also clockwise 4.5. So if this is force is in this direction, only HA into 4 equals to 4.5 plus 2.25 divided by, this is your HA equal to, this is the direction of HA will be opposite of this thing. So HA equals to how much? 6.75 divided by 4. This is your 1.6875. We can calculate, then you will find this. That is, we just remind, that is 6.75 divided by 4, 1.6875. We are getting this sway. The direction of sway is like this, like this. So we are getting, and rest at SD, because no moment, so this is your 0. SD is equal to 0, HA equal to your 6.75. The direction is from left to right. This is your direction. Okay. So यहाँ तक you have tried to understood this thing. You might have understood it. Next, we'll go for the sway condition. Sway conditions. So your final moment is this, and sway force is your sway equals to 1.6875 kilonewton in this direction. So because of this, the moment will go for the sway condition. What will happen for this sway? We'll get MAB equal to MBA equals to some value, but this will be negative value. So let us take some value. We can take 10 kilonewton randomly. बाकी rest there is no moment, so this is 0. So let us draw this thing we draw in this way, in this way, in this way, in this way. This is your like this is your 1 by 2, 1 by 2. This is minus 10.0, minus 10.0, and rest is 0, 0, 0. No moment in other point. So we have taken just 10. You can take some other figure also. Let us see the sway which is occurring over here is 10 kilonewton meter we have taken. So let us take this 10, resolve this is 5.0 plus 5.0. Your final moment will be, your final moment will be something like this. You can get some moment. This is your final answer. So this is a minus 10. Will get this get 2.50 like this. This will be 2.50, and this is your, this shift 2.5 minus 2.50 will shift here and will get 7.5. Sorry, minus 7.5. This is again minus 5.0. This is plus 5.0. 0, 0, 0. This is your moment which we are getting. So now for the sway conditions we are getting this moment, and what will be the HA? Let us see at this point. This is your fix. The moment is 7.5, means anticlockwise. This is 7.5. And what about this? This is also anticlockwise, 5.0. So your reaction will be, if you go like this, so your reaction will be HA in this direction. So HA equals to of 7.5 plus 5, and HA is equal to 12.5 divided by 4. So this will come how much? The direction will be opposite of this thing. This will be 12.5 divided by 4, 3.125. So we are getting 3.15, but direction is different than we have this kilometer. This is coming this much of load. This is much of HA. Baki rest is 0. HD equal to 0. We can find out the moment for this way 1.685. 1.6875 divided by 3.125, although the direction is zero, multiply by this moment. So we multiply this moment in this way. So this will be your 1.6875 divided by 3.125. Gives out 0.54. 0.54 into 7.5, 4.05. This you are putting G4. This is your 4.05. What about this? 0.54 into 5, 2.7. This is coming 2.7 minus 2.7 minus 2.7 plus 0, 0, 0. We are getting this value. So add on this value with this final moment. We are taking this 4.05 is taken here. How much? 4.05 minus 2.25, 1.8. So this is coming 1.8 minus 1.8 this is plus 1.8, sorry, minus 1.8, and this is plus 1.8, 0, 0, 0. So finally we are getting this moment 1.8. 2.7 minus 4.5, 1.8. So this is coming 4.5 minus 2.7. This is plus. This is plus, and this is minus 4.5 plus. So this is 1 minus. So your final moment is equal to, this is A, this is B, C, and this is D. A minus 1.8, B plus 1.8, and C minus 1.8. This is your B, this is your A, this is C, and this is D. So this is your moment which you are getting. This C is 0, this is 0, and D is 0. We are getting this moment. So we can find out the HA. What will be HA? HA will be this. Let's direction of HA is like this. Your 1.8 anti-clockwise. This is your clockwise. So HA equal to 0. HD equal to 0. Okay? Because both forces will neutralize, the moment will neutralize, and this HA and HD will be 0. So what will be the BA and BD? Let us see. This is your C point. So this is your BA and this is your VD. This is your load 16 kilonewton meter, and your moment E is minus 1.8, means anti-clockwise. This is 1.8 and this is 0. Okay. So BA, taking moment about this point, BA into 3, this is in this way, minus 16 into 1.5, and what about this? This is taking opposite to this, so this is also minus 1.8 equal to 0. इसलिए BA equals to 16 into 1.5 plus 1.8 divided by 3. BA, taking moment about this thing, DBD equal to 0, 0. So we are getting BA this 16 into 1.5 plus 1.8, 8.6. So we are getting BA 8.6. So BD equals to 7.4 because solar, this kilonewton, this kilonewton. You can draw the shear force and bending moment diagram in this way. Let us draw the BMD. For the AB portion, this is 1.8 anti-clockwise. So anti-clockwise means trying to go hogging. This anti-clockwise means hogging. Anti-clockwise means hogging. So this will be negative. So take a negative. What about this 1 plus 1.8? This is taking also hogging. So this is your same. This will be negative and value will be 1.8 kilonewton meter. What about this thing? This is coming minus 1.8. Minus 1.8 is anti-clockwise. This is also negative, and at this point is 0. This is like this. And in this point there is no moment, but there is a moment in this way, positive, that is W L by 4. W is 16 into 3 by 4, that is 12 kilonewton meter. This is 12 kilonewton meter, and this is your how much? 1.8 negative. तो 1.8 का हाफ यहाँ आ जाएगा, So this is 0.9 and this will be your value will be, this value will be 12 minus 0.9 kilonewton meter, that is your 11.1 kilonewton positive. So this is your BMT. Similarly, we can draw the shear force diagram also. You can draw the shear force diagram. If you try to understand, you can draw the shear force diagram also. BA equals to 8.6 and 7.4. Rest is 0. So we'll draw the shear force diagram in this way. This will be 0. You can have some energy from this in this way and we'll draw the shear force diagram. This is 0, this is 0 and we are getting here 8.6, here we are getting, so it will go like this. This is 7.4, this is your minus, this may be your positive and this may be positive, so this will be negative. So this is your SFT, shear force diagram. We can draw this shear force diagram. Or this is your bending moment diagram, this is your bending moment diagram, this is 1.8, this is 12 point something. So we can draw the shear force and bending moment diagram. This is how we will tackle this problem when EG is imposed somewhere in the joint. So thank you for attending class. Thank you very much.